Hi, good afternoon, everyone. Okay, so for the next 18 minutes, or thereabout, I hope, I'm going to talk about this idea of curiosity-driven design, which is about how, as designers, we take insights and experience from our kind of everyday, and we translate those into products that really connect with people in new ways. You know, how we translate these ideas. And so I hope over the course of these 18 minutes, I can show you some beautiful things and inspire you to think about materials in a slightly different way to perhaps how you came in. But let's see how it goes. Okay, so first of all, I'm just going to kind of introduce myself, set the scene and the context, because this needs a little bit of background. And then I'll talk through the structure of the presentation and kind of what I'll show and the journey we'll take. So first of all, I'm a designer at Nokia. I'm working in Finland at the moment, which is quite an experience, and it's very interesting to see the kind of analysis of all these different countries. I've had the privilege of working in many and visiting many countries, and Finland is quite an incredible place, and I'll come on to that a little bit in more detail in a minute. But I'm also a writer. I travel to factories all over the world and research materials and technologies and try to understand what innovations there are that we can use, what things are changing, the way we might make things or build things, and what's inspiring, what's curious to me as a designer, because that's what really feeds my creativity. So first of all, this is an example. It looks incredibly complex, right? There's a huge number of different fibers going down onto a drum. But this is an example from North Sails in America, where they're actually making sails in a single piece. Now, conventionally, sails are made in the same way as you would cut cloth for a woven garment, where you cut patterns to fit the shape of the dress or the shape of the suit. And you can imagine there's lots of overlaps, there's lots of stitching. But in this case, they've managed to create computer-guided rollers that enable them to form sails with a flying shape in a single piece of material. You can imagine the huge benefit that gives, the huge weight saving they get from this technology. An incredible innovation, but something that at the moment is only used in sails, but just think of what this could be used in the future. But let's not forget, there's all of this technology, all of this amazing innovation happening. There's also some incredible skill still. This photograph is from a factory in the heartland of ceramics in the UK, in Stoke. And this is the making of a ceramic plate. And it's just amazing working with some of these people. They have incredible insight and skill with materials, something which is becoming ever more important in today's world, when we become more accustomed to technology and more used to things being virtual and ethereal. But what I like is taking these sort of simple observations. So what does it mean to be within our surroundings? You know, this is an exhibition that we put up at night, and so it was all dark. And in the morning when we came back in, the light from the windows was coming through and, putting these patterns on the paper. And it's just incredible to think that our surroundings are so complex, and yet we create these products that sit in this world. You know, how do we create those products to meaningfully connect with both us and our surroundings? And so I just wanted to show this, which is a really nice example. It's called Litricon, and it's a combination of ceramic and concrete and glass. Combining these two materials that are very good under compressive loads means that you get a construction material, but that it has silhouettes and shadows, and the light affects it. And it really changes the way a material can be perceived. But what does that mean in the digital space? This is one of many kind of examples of systems of interaction that could be considered binary. They're either on or off. But how do we get that multitude of shades of interaction that we're used to in our day-to-day lives? How do we connect with people in new and exciting ways with materials? So that's kind of where I'm coming from in this, and I'd like to start with a quote from The Material of Invention, which is a book by Ezio Manzini. And this is somebody who I've got the utmost respect for, and ever since I discovered his book at school, I've used it as my kind of constant source of reference. And it starts that a material is something that under given conditions, a system of loads, environmental conditions, an observation period, behaves in a given fashion. That is, it supplies certain performances. Now, this can be read in two ways. First of all, it can be about the mechanical function of a material. But I like to think about it also in terms of the personality of a material. You know, materials have characteristics, and how as designers do we pull out those characteristics, but also start to challenge those experiences and actually bring new insights and new ways of connecting to materials into our products and into our day-to-day lives. So I'm going to talk through these kind of three areas in this presentation. First of all, just a little bit about the characteristics of materials and how as designers, like how I as a designer interpret materials and understand the qualities that I can get from them. A little bit about some of the leading kind of material developments in industry, a few little insights from the many travels that I've made. And then finally, just a few ideas about how actually we can start to challenge material experiences in the future and what that might mean for products going forward. Okay, so I promised I'd talk a little bit more about where I'm living at the moment, and this is where I call home. And actually, this is kind of what it looks like at the moment. It's still snowing in Finland, believe it or not. So it's very nice to come to Thessaloniki and soak up some sun, I must say. But I just wanted to point this out because the personality of materials is not anything new. It's not a radical concept. It's something that both designers and everyone is very familiar with, right? And the reason why I've put this slide up here is because I found over the last year and a bit of being in Finland that they have more than 150 ways of describing snow, the kind of characteristics of snow, and snow itself. Now, snow is just frozen water. So what does that mean? You know, how complex can this stuff be that actually we need all these different ways of characterizing the material? And so just to put that in the context of an object, you know, we take, for example, a three-dimensional object in a space. It's in a white space, it's red, it's glossy, it's kind of hard, it's kind of warm. But what happens if we turn that into metal? You know, does that then become much more precious, more solid, heavier perhaps, colder? How does it sit within its space? It's reflective, so the space changes around it. And that's just a very, very subtle change. There's no mixing of materials. It's purely a change in the surface appearance of the material. And then we turn it on its head. How about we cover it in a flock, a velvet-like surface? It becomes softer, it becomes friendly. It becomes something you want to pick up, perhaps, and touch and hold. You know, how we interact with these objects is what really fascinates me, and how we challenge that is what we'll get onto. So, just a talk through some material characteristics. I've got some slides, some nice big pictures, and just as a designer, how we interpret these things, I think is very interesting. So first of all, this is a project that took place at Nokia, and it doesn't look like a mobile phone, because it's not. But it was a really, really nice project that was about pairing up designers who are every day working on mobile phones. And you can imagine that creates a sort of bubble because the requirements are so demanding, the technical constraints are so specific. With people who specialize in materials, craftspeople who specialize in different materials. And this, of course, is a piece of glass. And it's really beautiful to think about how a designer that's very constrained by mobile phones and a craftsperson who perhaps doesn't understand the complications of mobile phones come together and start to explore material characteristics. And actually, they realize that we take a lot of things for granted. You know, the different surface transitions of these materials is very important. And then something very different, materials that live, that have a life, that have experiences. Wood is completely unique every time you cut it. It has a smell. It's very familiar to us. And it's just interesting to think about the contrast of these different materials and what they mean to us, what a glass floor would mean versus a wood floor. Yeah, it's very different. But then also, we couldn't go through this whole presentation without talking about plastic. It's completely all around us, right? And we take it totally for granted, but it does have some beautiful properties. And this is just a straightforward pieces of acrylic. They have this phenomenon known as edge glow, and it's something that's used in signage and packaging all around us. But it's this idea that actually light is absorbed in through the surface and refracted internally and out through the edges, so they appear lighter than the surroundings. And it's a very beautiful quality in something that we consider so superfluous and ubiquitous. And then this, which looks like kind of quilted fabric, but you'd be surprised to know it's actually stainless steel, structural stainless steel. And the surface has been chemically altered so that at a nanoscale, it interferes with the light in much the same way butterfly wings appear colourful, by splitting light waves and actually giving you a colour in return. And something, again, a plastic-like material, but this one derived from natural sources. So this is cellulose, which is derived from wood, and it's the same thing that is used to make my glasses, and it's all around us. But it's beautiful to think about how these materials come into being too. Wood is grown, cellulose comes from wood, and cellulose is created by mixing these different colours and materials together in big rolls. And you get these incredibly beautiful, very tactile material experiences from something which is essentially just a plastic. And then this is another example of a project that's actually happening now at Nokia, and I think is incredibly interesting and very beautiful. And it's this idea actually that, what happens if we move away from the very physical, the very tangible, and we start to try and understand, as materials designers, what things like fluid dynamics mean to us, what they mean in terms of tangibility and intangibility. And this video demonstrates some of the work that's ongoing on that project to look at and understand the sort of sensorial properties of some of these materials and how they mix. And I'm always delighted to see new presentations coming back from these guys because they're incredibly inspiring. But to think about how these start to translate into the way we create and design products is really quite inspiring. Okay, so we'll have a quick look at some kind of leading material developments, just a few insights from the many travels that I've been on. This is quite interesting because it's a ceramic material. It's a very large piece, but it's machined to incredibly precise dimensions. And it's an incredibly high-performing material too. But for a designer, it's got very desirable qualities. It's cold to the touch, it's powdery or it's glossy. It has very premium qualities too, which is something we're always trying to connect with, so very beautiful. But in this case, it's being used for very technical applications. And this also, these are little strips of metal that are used to test the strength of aluminium alloys. This image was actually given to me by Superform Aluminium, who are a company in the UK that have developed a way of forming aluminium alloys that's much the same as plastic. You'll see this one in the middle that's stretched like chewing gum. Well, that's exactly what it does at a certain temperature. And they use this to make huge undulating shapes in a single piece of material. And you think of the difference that makes to a product when you can start to create something without seams, without joining. But then also the more everyday. Like, it's incredible to think how complex manufacturing is for some of our very everyday objects. So this is the three-dimensional knitting of a polypropylene or a plastic sack that might hold our foodstuff or animal feeds or whatever. But the amount of engineering and development and optimization that has gone into this is quite incredible. And like, as designers, it's easy sometimes to take it for granted, actually, the wealth of knowledge that exists in our factories and how we draw on that and understand its benefits for the product design process. And then this, which is much more humble as a material, I think. This is a material called tree plast, and there's actually no plastic in it whatsoever in terms of synthetic plastic. It's a combination of wood and natural resins. But what's incredible about this material, which has been around for a few years now, but what's incredible about this innovation is that it's actually injection molded, which is something we're very used to in our everyday plastic products. But just think what could be in the future if we were able to harness our industrial waste and turn it into these very different types of wooden product. And this is an example from a company in England that are constantly innovating in terms of joining. They're called TWI, and it might not look like much, but this is wood joined without anything else added. There's no nails, there's no glue, there's no nothing. The wood has been joined together by welding, which is a process we associate with metals and plastics. And it's quite amazing to think what will happen in the future if actually we can start to bring materials together in very different ways. Similarly, these small metal parts, which I admit don't look like a great deal up on the screen, but they've been made by a company in the UK called Metal Injection Molding, and they're actually taking metal elements in their particle form, injecting them just like we do plastics, and turning them into these very precise and intricate metal parts. Imagine, cutting these using a reductive process from metal. It's quite different to think about how we can actually form these materials in different ways. So we can start to juxtapose materials with the way that they're manufactured, with the way that they're used to create these new material experiences. So, I'll just finish up with a few slides that just show some ideas about how, as designers, we think about the future of material experiences and how we might experiment with those material experiences. Because this is the bit that I love. I mean, this is the bit that I work for and that I look forward to. So first of all, the important thing is we have to get our hands dirty. There's an awful lot of work these days that happens on computer. And it's very easy to forget, actually, what materials feel like, which is why those projects I was showing you from Nokia are so important, because it's about connecting people with the materials that they're working on. So getting in the workshop, trying things out, understanding three-dimensionally what stuff means is an incredibly important process and an incredible amount of fun for a designer. And so just to finish on 3 examples. The first one is a project that I did several years ago, actually, that was to try and take plastic and recontextualize it. So I mixed plastic with lots of other materials to create a 3-dimensional material that over time, with longevity of use, would actually age and change and wear according to how it was used. So you'd build up a relationship with a material that you consider disposable, perhaps throwaway, and what that might mean for the consumption of the material. And the second example, this is a man-made material, essentially, and it's excavated. This is from the floor of a photographic studio where over many years, layers of paint have been put down day after day for every different sort of car they photographed or model they photographed. And it's incredible to think about what the future will be like when we start to take man-made materials and excavate them again. How do we think about whether they will be beautiful, whether they will have endearing qualities, whether they could look as lovely as this? And the final example is from another project at Nokia. This was similar to the glass project in that a designer there was paired with a craftsperson. But interestingly, this craftsperson specialized in working with computer data. And actually, what's fascinating about this for me is that they've managed to sculpt surfaces through their knowledge of materials, but in the virtual space that is then created in the physical form. And it's just very interesting to think about how the future may look when we start to understand the materials in both the digital and the physical space, and we connect people with these types of material experiences in very new and novel ways. Okay, thank you very much.